like. For example, so for you don't need to worry about the detailed numbers, just to give an overall sense. So for example, we have some model based on overweighting, and it improves, the relevance for a little. But when we are combine the relevance and the freshness, the improvement is much larger. And here is the comparison in chart graph. For example, the red one is demoted, and the blue one is non-demoted. We find that if we consider the recency on the demoted relevance, demoted evaluation metrics, the improvement is much significant than before. Okay, the next part is some of the session-based click features for recency ranking. The challenge, as we discussed, for some of the new queries and the new document, click information is very sparse. So very limited clicks on the fresh documents. And those fresh queries may not have relevant URLs for users. So here is one example. So the original query is circus. It is in a query session. So because Brandy, I think she have a new songs in around 2009. The name of the song called Circus. So at that time, many people search this query. And here is a typical query chain, which means we monitor the user behavior in the search engine. First, the user input the query circus. And at the beginning, the search engine result is not covered the new song. So the result is about some circus show or about Wikipedia about circus. So user is not like it, doesn't like it. So he changed the query as circus urban. And there is a query, there is a document about the circus song from the Britney Spears. But the user still not satisfied. He searched the query Britney Spears circus urban. There's missing one character. He searched the query with 4 tokens, and finally he finds the official website. So the user clicked it, and that is the whole session. So what we can derive from this user session? So here is some background. So Britney Spears released a new song in late 2008, and this query is only related to the circus show, and these queries are related to the songs. And here is some of the user views, right? Based on the views of the search engine result, we find starting from here, right? More and more user click here, click here. How can we, derive some of the new features to solve this kind of click sparsity issues? So we leverage query chain, which means we consider the multiple query within the same chain for a given query and trying to derive new features. And because we believe that user may issue a chain of query for the same information need. And the queries within the chain, they are strongly correlated. So therefore, we could use the query chain to smooth the clicks, as I discussed, trying to extend the click from one query URL pair to multiple URL pairs within the same query session. For example, here is the original user behavior. First, search this query, no click, then change the query, one click, then change another query, Britney Spears, circus ambient, so this one capital, have another click. What we can learn from this? First, we believe if a user input the query circus, we can believe that actually this document is also related to this query. Similarly, this query also relates to the official website of this new song. And similarly, we can align this query with this document. So as a result, we can do this kind of smoothing and expand the original sparse of this kind of correlation between our query and the document, and improve the coverage of the query. So, and similarly, we can derive some other click features which is related to the which is aggregated in among period of time. And with this kind of smoothing, we can improve to like something 12%. And then we can leverage those kind of click feature, which means add more weight to the recent clicks than the old clicks. And finally, provide it as a new feature, and it can improve, statistically significantly improve the time-sensitive related queries given these queries, and given these new features. Okay, the third one is about how to rank some of their breaking news query or newsworthy query with the Twitter data. And this one, and this work is related both to data and new features. So first, we believe that incorporate Twitter data, we can improve the real-time web search. But I mean, this work is mainly to improve the web search ranking, not Twitter search. We have separate research on Twitter search, but this work is trying to leverage Twitter information to improve web search data. And as we know that Twitter is one of the most popular microblogging system. And on Twitter, there are different terminology like tweets, which is a small text within 140 character. The Twitter users, which can issue different tweets, and they can follow each other. And tweet tiny URLs, because each tweet is very small, so given some long URLs, Twitter users will make it into a short, tiny URL, and different users have following relationship. And here is some example. So what we can find is different Twitter users, they send different tweets, but the different tweets contain the same tiny URL, which means they contain the same news article. If this news article is a breaking news article, what we can see? Because a very fresh news article, as we can see, they have very little click information, they have very little anchor text information. However, if we find multiple Twitter users, they issued different tweets contain the same tiny URLs. We can consider different tweets as a kind of extension of anchor text, which means these different tweets are good representative for these news articles. So this is the motivation of this original paper. So this research, and we are trying to answer several questions. The first question is, can we make use of Twitter to improve real-time crawling? And can we utilize tweets to improve Twitter tiny URL ranking? And the third one is, can we leverage the social network of Twitter users due to the follow or following relationship to improve the Twitter tiny URL ranking? So the motivation of this research is, we find that Twitter tiny URLs contains some news or non-news URL. And the Twitter tiny URLs could represent the diverse and dynamic browsing priority of users. The idea is similar to crowdsourcing, because single crawling strategy may not find the best breaking news content. However, if we can leverage the Twitter tiny URL, because Twitter users, they care a lot about the breaking news content, we can leverage them to enrich our crawling strategy. The second one is the social network among Twitter users can provide a method to compute the popularity of the Twitter user, and which corresponds to the authority of the fresh document. For example, if Lady Gaga, right, she cares about a breaking news event, something like Japan earthquake, right? She has a lot of authority about the news. For me, I'm not an active Twitter user. So if I, comment or cite any breaking news articles, it is less important than a celebrity. And the third one is tweets can be leveraged as extended representation of tweets' tiny URLs. The important is something like anchor text. Okay, first is about the crawling strategy, because the internet is very huge. So there is no any search engine can crawl all these kind of articles. So exhaustively crawling strategy for fresh content is difficult, impossible. However, we can select high quality tweets tiny URL as a kind of extended crawling seed. And starting from this extended crawling seed we can crawl good fresh content. And since Twitter tiny URL, they reflect the diverse and dynamic browsing priority of users, and human intelligence is incorporated into our real-time crawling and indexing system. So in our examples, we find first, the majority of the Twitter tiny URL are poor quality. They contains numerous of spam page, elder page, or commercial self-promotion page. But we can leverage some simple heuristic rules. For example, we discussed some low-quality Twitter tiny URLs and only focus on those we believe high-quality one. And based on our experiment, we leverage 5-hour Twitter data and collect about 1 million tiny URL. And based on our filtering strategy, and we collect around 6% of them, we believe they are high quality. And the next is about the ranking features. As I mentioned, the ranking feature overall is very critical to the ranking model. Here we can categorize features from a different scale. First, some of the features are related to content. They only relate to content. For example, some of the features are only based on the content of a document or a query, and some query term matching features, proximity features. Those type of content features, they are insensitive over time. So which means we can trustably leverage them, although these features are not updated. And some features, they are aggregated. For example, the click feature, the anchor text feature, the page rank features, they are aggregated, which means those kind of old documents are more favored based on aggregation. And this feature reflects the authority and popularity of a page. They are sensitive over time. So they are unfavored to fresh document. These are typical features we categorize into time-sensitive or time-insensitive features. However, we can still extract some feature just based on Twitter. For example, we generate features from tweets, from Twitter users, and Twitter tiny URL document. This type of feature provide extra signals to document relevance in real time. And for example, for Twitter feature, first is the Twitter text feature. We can compute the text matching or proximity between a document and a tweet. We can compute, for example, the constant similarity, the matching, the aggregated, the user weighted features. Because as we discussed before, some of the users their weight is heavier. Some of the users their weight is lower. So we need to leverage the user authority together to generate the feature. And the rationale between the query and the tweets, as we discussed, so tweets can be leveraged as a substitute of anchor text feature in real time. Because for new news article, for example, there is a very limited, almost no anchor text at all. So we can leverage this kind of tweets as a substitute of anchor text information. And another family of interesting features is the social network features. Because there is some because Twitter users, they construct a social network. If we consider each, in this network, if we consider each vertex represent a Twitter user, and the edge is represents the follow-in relationship, then we can apply the page ranking idea or any similar random walk idea, which can derive the popularity of a Twitter user when it converges. And this kind of popularity information is used here to aggregate the text matching information. For example, if we consider the page rank, then the Lady Gaga, his Twitter account will have a higher score, and my Twitter account will have a low score, something like this. And there are some other Twitter features, something like given a tiny URL, what is the number of the followings for this URL, what is the post for this user, etc. And yeah, this type of feature can be also aggregated with PageRank related user importance feature. Okay, finally we leverage the different features and apply some divide and conquer strategy, and we train two separate models and then try to blend them together. And for regular URLs, we use the regular data, which means only use the content feature and aggregate features. For those kind of Twitter tiny URLs, because those kind of Twitter tiny URLs may consider many very fresh articles about some breaking news. This kind of breaking news is not indexed in our general web search engine. So for this type of URLs, they generate, we mainly leverage the recency data and leverage the content features. Here since the aggregated feature is not trustable anymore, so we leverage the Twitter features. And then combine these two type of together with some divide and conquer strategy. And here is, and also leverage the GBET, and we can get some very promising result. So for breaking news, by the way, for this type of queries, we need to know whether our query's intention, whether our query is a breaking news query or not. So we leverage our query classifier, which has high accuracy. And for URL, we consider the top-ranked regular document and also the Twitter tiny URLs in the last some windows. And finally, ask editor still to do some labeling based on the relevance and based on the freshness. And the result and the evaluation also trying to combine these two dimensions of judgment into one with a demotion strategy. And so we can find, for example, for the training data, the regular training data is much larger than Twitter tiny URL data set. This is a labeled data. And in terms of the features, so we find on this data set, only 66 features, they are insensitive over time. And the majority of features, they are sensitive over time. And we can generate another 20 features from the Twitter data. And in terms of the evaluation, so we mainly leverage the recency demoted DCG. And because the Twitter tiny URLs, it's for regular URLs, its recency its freshness is not good, and for Twitter tiny URL, its recency is much better. This is in terms of percentage. And here is the ranking result. Finally, if we try to use our divide and conquer method and blend two ranking results together, it can improve the demoted NDCG for like 10%, which is very significant. Okay, here is some major findings for the recency ranking. So 3 major findings. First is we find that Twitter, they did contain high quality Twitter tiny URL, which is relevant to some time-sensitive queries. And then we find the text of tweets can be used to substitute anchor text for those real-time relevant document. And another finding is the social network of Twitter users can be used to incorporate, to improve ranking result. Okay, the next part I'm talking about how to re-rank some of the recurrent events based on some control feedback adjustment strategy. So this work is some...
Just a quick question.
Yes?
Sorry to interrupt. So on the Twitter data, yeah, can you see me? Yeah.
Could you please stand up? I do not... Oh, okay.
So, frankly, search engines have kind of lost the breaking news thing completely to the social network, right? This is more of a catching game that the search engine is doing to play up with the social media. People go to social media to find the breaking news from the followers they have handpicked, right? So, what you showed was more of how to aggregate this information for the wider audience on the general search engine. But the important factor about the social media is that they also incorporate the followers part. Do you plan to take that into account for example, something that is breaking news for a group of people may not be a breaking news for other group of people. Right? For example, something that is breaking news in Bangalore is certainly not a breaking news in Los Angeles. So the followers and all these things actually constitute this aspect. So do you have plans of generalizing this thing to incorporate such context into the ranking thing?
Okay, I think, it's a very interesting problem, and this problem can be solved from different strategy. First is, there is some request for ranking from the personalized point of view, which means, not talking about social, which means some users, they want their search engine to be well-tailored according to his own interest, right? This is very important, which means we may need to keep some user profile for each query, for each user, and then adjust the result according to the user's profile. For your question about the about the user on different countries, that problem is relatively easier because we can identify a user's region based on its location or IP address. For that one, it's relatively easy, which means for different country, we provide a breaking news query according to different country or different region. And there is another part for the social part. For social part, it's a very new challenge. So just to provide the ranking result based on Twitter itself, maybe it's relatively easier. However, currently many search engine provide the service that can connect its, for example, Yahoo's account with his Facebook account and the Twitter account. Then how to combine this kind of social interest to reflect the search engine result. So for this type of work, there are some research on it, but there is some argument. So whether we need to, change the search result on the top position, which means how much user really want the social update at the top of the search engine is still arguable. Something like Bing, they are doing some study, they're providing some result, but it's shown on the right rail, which means they provide the social update or social content as a kind of complementary to the web search engine result. But instead, they're trying to avoid to put the social update, social result, to dominate the search result. So anyway, I think it is something really important, and different researchers on different companies are still working on it, but there is no conclusive work yet. Okay, this part is we're trying to handle the recurrent event queries. For example, a query is spring hair style. So if the user sent this query in this year, right, we want to find the spring hair style in 2013 instead of get a result from previous years. And similarly, if a query is a conference like ICML, returns the ICML previous conference, doesn't make sense at all. For this type of queries, because they have very unique patterns, something like I said CGR. If we search CGR now, maybe CGR 2013 is relevant, but CGR conference is held in sometime in August or July. If I search the query again in September, October, we may need the result of the next year instead of this year. So because it has some unique patterns, so generally the machine learning ranking model may not work. So we're trying to solve it into a different method. That is trying to rewrite the queries. During the break, someone asked me a question like, for some type of query, the query is very long. For example, contain 10 different characters. Sometimes the characters have some type of spelling problems. How to solve this type of query? So generally speaking, for a big family of queries, to solve the ranking problem, we also need to help from the query analysis itself. For example, we need to rewrite the query. If a query is misspelled, we need to correct it. And for this type of recurrent event queries, we can add some tokens to the query. For example, if a user search for CGR, and we already find the user patterns in advance. So if people search CGR this month, we can internally convert the query into CGR 2013. If a query searches a query again, CGR in November or December this year, we can change the query to CGR 2014. But if we just do this, there are other problems, which means it doubles the search, which doubles the latency of the search engine, which is not good. Instead, we're trying to do the similar idea, but use a feedback control score adjustment strategy. For example, we know the ideal, we know the desired ranking is something like this, and the current ranking result is like this. And then we can, provide a detector model and adjust the current ranking result to reflect the ideal ranking result. For example, given the query, you can, for example, given a query to a simpler case, think about it, this is just some conference like a CGR, and assume that this is the ideal case, and this is the current result. So instead of totally we re-rank the whole result, we just trying to add some extra bonus to this result and trying to provide the best result onto the top position. And all this kind of strategy is we can maintain some rule-based method and provide the adjustment. And compare with some other solution, this method can improve the recurrent event for more than 60%, more than 6%. And finally, that given the result, so we can, because this result are shown in 2009, So given result like spring hair, we have the 2009 result, and like a review, we also have the recent result. By the way, this kind of adjustment is not based on single URL. It's more like based on a URL with the good year, so which means a bunch of the URL which have the good result. For something like in the year of 2009, we're trying to boost the document on the title section with 2009 some extra score and add all of them, so they can provide a much better ranking result. So this is some of the study related to the how to rank the fresh score in the web search. And in the next part, I will introduce how to provide the ranking for vertical search engine. Because there are some historical reason. Is at some time we are trying to working on different method to improve the freshness content for web search. A typical question is, since you have multiple solutions, why not combine them together? The reason we do not work on this research is because at some time we are working on that, but before we work further step, Yahoo deciding to have some partnership with Bing. So as a result, our focus switched from the web search to vertical search. So for vertical search, which is also important, as I introduced before, because nowadays only very limited search engine companies survive, only 5 or 6 search engine companies. So for many small startups, right, there's no chance to join this kind of search engine competition. But if people have interest on search problems, there's still some opportunities for vertical search. For example, nowadays there are many new startup companies related to local or mobile or social related tasks. And how to provide a good ranking result for different search engine is a challenging problem, because different vertical search engine